which is about
Let's say your business is doing well.
what exactly is lean management all about. So just let me know if you are able to see my screen. Also, if you can hear the sound as
And you're thinking of expanding. That's great, but it's
well. Can you hear the sound, everyone?
Yeah, yeah. Can hear and see.
Okay, perfect.
let's say your business is doing well and you're thinking of expanding. That's great, but it's also the riskiest time for your business. In fact, many businesses don't survive the transition. Should you throw money at the problem by investing in new equipment or hiring more people? Should you make your staff work more overtime? Your answers to questions like these can make or break your business. And that's where Lean comes in. Lean is a philosophy about delivering value from your customer's perspective, eliminating waste, and continuously improving your processes. Lean can radically change the way you do business. Lean management is based on 4 principles. The first principle is pull. Rather than producing as much as possible, customer demand pulls goods or services through the manufacturing process. This minimizes overproduction, inventory, and ultimately working capital. The second is one-piece flow. Focusing on one single piece at a time minimizes work in progress, process interruptions, lead and waiting time, while increasing quality and flexibility. The third is tact. It's the heartbeat of a lean system. It's how fast you need to manufacture a product to meet customer demand. Tact allows us to balance work content, achieve a continuous flow, and respond flexibly to changes in the marketplace. And the fourth is zero defects. Mistakes happen, but a lean company doesn't pass on defects. Mistakes from previous steps must be fixed before going on. Combined with a robust continuous improvement process, the 4 principles of lean management will help your company stay ahead of the competition in a constantly changing marketplace. So, if you're ready to begin your lean journey, contact us to
Perfect. So this was the concept that we had discussed last week on Friday when we had said goodbye and we met today. We were discussing a couple of those things like lead time, tech to time, and value stream map. If you remember, we were talking about the yield concept where we said before we move to the next step, the rework from previous step should be added to the input for the next step. And we also finished. I talked about the overview of hypothesis testing, and we started some hypothesis test also before.
Kevin, excuse, it's blurred.
One second. One second. I think now it would be very clear for you guys, right?
Okay, it's good.
Yeah. Sorry, that was optimized screen for the video. So before we finished our last week on Friday, we talked about hypothesis testing, and that's when we stopped. So before we begin the session today, any question that you may have from the last session or from that last week? Anyone? Any question? If you have gone through the recordings, I'm sure if the recordings, if the recordings have been shared with you, and if you have gone through the recordings, then if you have any question, you can ask me now before we begin. Okay, so if there are no questions, I'll do a very small recap of what we did last week in a very quick nutshell, and then we'll begin. So far, what we have done is we identified the customer. We collected customer requirements, converted into measurable requirements, which is CTQ. And then we prioritized customer requirement using Kano, and we put them into a document called as project charter. Then from after project charter, we assigned the roles and responsibilities to all the team members using a method called as RACI diagram. And from RACI, we also prepared a communication plan about the project, how we are going to communicate the status and success of everything about the project to every person. And we also did a stakeholder analysis before we even begin the projects to understand who is aligned and who are the key stakeholders and whose support do we need in this entire project. And at the end of the defined phase, we understood the project process as a high level, which we called as SIPOC, supplier input process output customer, that helped us to understand the boundary of the process. And that's when we had the define phase tollgate review. Now we have a problem, we have a process, we have a project defined, and now we would like to collect data about the project that we are working, the problem we want to solve. We will collect data, and that data is called as a sample. Sample, as a rule of thumb, should be uh, representative. When to make it representative, it should be stratified random sampling. And the data that we are gathering of sample, that can be of two types, discrete and continuous. So that's what how we're collecting the sample. Now, the sample that we have collected, we're not sure the sample is coming from a reliable source or the sample is reliable also or not, or how much variation exists in the sample. So to understand that, we use some method called as, let's say, control chart. Control chart will help us to understand what type of variation exists in a process and is the process in control or not. So there are two types of variation that exist in a process. One is common cause, second is the special cause. And special cause variation needs to be identified, investigated, and eliminated. That's the three things we have to do. What is special cause? Because we also looked at the variation in a process using some other methods like histogram, box plot. They help us to visualize the variation in a process. And coming back to understand if the process coming from reliable source or not, we did a measurable system analysis to understand is the process, the source, or the data that we have is reliable or not. So for the continuous type of data, we used a method called as gauge RNR, where gauge stands for machine and RNR is repeatability and reproducibility. When we looked at gauge RNR percentage, variation percentage should be less than 10% of total variation in the system. And number of distinct attributes should be more than or equal to 4. While for discrete type of data, we looked at AAA attribute agreement analysis. And there we looked at the kappa coefficient, which told us, do the appraiser are agreeing with each other or not? Or is there a match? How much they are matching with each other in terms of their measurement? This is how we understood. So now we realize that the data is fine coming from reliable source. We then understood the capability of the process using the capability analysis. And for continuous type of data, we use CP and CPK. CP should be at least 1 and ideally is 1.33. And CPK told us how off center we are from the target. And for discrete data, we used a method to understand the capability of the process. We call DPMO, defect per million opportunity. And using the DPMO, we could also calculate the sigma level of the process. We then also looked at the yield of a process. Yield told us that the rework or the scraps or damaged products or goods, how they bring down the overall productivity or yield of the process. That's how we then we also look at as part of measure phase. Now we know the capability of the process. We know what kind of variation exists. We also know whether the process is in control or not. Now is the time we should map the entire process end to end and then see what type of where are the bottlenecks, where is the process getting slow, where are we making more defects. So for this, we map the process at a detailed level and we used swimlane diagram and value stream map. These two methods help us to understand what type of waste exists in a process, where are they existing, which step take which step take a lot of time, the waiting time, approval flow, at which step it is happening more. We understood there are 7 types of weight which can be summarized using a method called as TIMWOOD. So TIMWOOD is the acronym for transportation, inventory, motion, waiting, overproduction, overprocessing, and defects. Also rework. So that's what we did as part of the measure phase to understand that there are different types. We need to look at a process. We are not identifying root causes or building solutions yet. We're only looking at a process from multiple angles, from various perspectives, just to understand different parts about the process. And we can get multiple things. For example, CPCTK we get, DPMO get, sigma level, lead time, process time, types of defect, different waste we'll understand, mean and median of the process, standard deviation we get to know. So all these things we get to know from the measure phase. So now is the time when we have all this information about a process, what is possibly happening in a process, what is wrong in the process. That's the time we need to understand what are the potential causes in this process which is causing so much problem. So to do this, we need to collect a lot of potential problems about the process. So for this, we use the brainstorming method and put together everyone, a team, and we use a fishbone diagram to understand what are the potential causes. And the team came up with a lot of ideas, 50, 60 ideas on different parameters using the fishbone. And then we prioritize them using control impact matrix and also Pareto chart used that helped us to identify what are the top 20 potential causes that is causing most of the problem. And then from the Pareto and control impact matrix, we could bring down those potential causes, a list of 60 to let's say 15 or 10. And then we did a root cause analysis method called as 5 why analysis to understand what are the actual root cause of these potential causes, where the potential causes are pointing to, what are those root causes. And those root causes list we got at the end. But this is when we do not have time, when we know somehow about the root causes, some idea we have about the process, and we have to improve it quickly, we use this method. But the potential causes that we have collected using fishbone, the right thing is to go back and collect the data for all those potential causes. And each of the potential causes, we need to build a relationship between the potential cause and the effect that we have. Effect is the process that you're trying to improve. So for this, this relationship we'll call as hypothesis testing, which we studied last week on Friday when we said, if I'm saying that the experience of an individual, experience of an associate impacts the time they take to do a job, if that is my hypothesis, so I need to prove this before I say that the experience is an important factor in the total time an associate takes to do the job, previous experience. So we established a null hypothesis which says there is no correlation, they are not same and there is no difference. That means experience has nothing to do with the time a person takes to do a job, because if it takes, you have to prove it with data. So null means two things are not correlated and they're absolutely same. So we talked about alternate hypotheses, then we talked about the p-value, the probability value. So we discussed that if the p-value is less than 0.05, which is called a significance level, which we have set as 0.05 or 5% of total risk. So here we talked about that we have to set up a risk level, and that anything going beyond the risk level, I will not accept it. I will simply say that I'm not very confident because my risk is increasing. And the standard or benchmark is around 5%. You can also change it 1%, 10% also, depending on how complex the problem is. We talked about the probability value, the probability p-value, if it is more than 0.05, we accept the null hypothesis. That means we do not find that there is an evidence of one thing impacting other. If the p-value is less than 0.05, we reject the null hypothesis and we say that there is a probability that one thing is impacting the other significantly. We also talked about two types of risk, type 1, type 2 errors, alpha, beta risk we call it. And then we built an entire roadmap of the hypothesis testing, which is this. This is what we built, and this is what we discussed. So from this entire list of hypothesis tests, we discussed the when y is continuous and x is also continuous. We did the correlation test. We also did when y is continuous, x is discrete, and we are looking at the centering of the problem. We did two sample t-test and paired t-test. These two tests we did. There's few more tests which are in the scope of Greenbelt training that we'll do here. We'll do an ANOVA and we'll do other tests. So any questions so far from anyone? That is how we have done last week. We are using hypothesis tests to segregate the list of causes impacting my y significantly. Whichever is not impacting, I would take them off. But hypothesis test will help me to filter and will help me to prioritize also. Okay, if there are no questions, then in the list of this, we'll go further where y is continuous type of data and my x, one of the x is discrete, and we are looking at the centering of the problem, how off center we are. So we looked at two sample t-test, we looked at paired t-test, but two sample t-test and paired t-test, if you read the recording, sorry, if you heard the recording, if you were there in the last session, I talked about only two samples. when I have only two samples to talk, when I'm comparing the performance of two different groups. So I'm using a test like two sample t-test when samples are different. And if samples are related or the same sample, but I want to check performance before a solution and after a solution, so I'm using a paired t-test. But this is only for the two samples. What if I want to compare more than two samples together? I want to compare three samples, or let's say four samples, or five samples, or more. So I cannot use the two sample t-test or paired t-test. Then I need to use a method that can help me to compare performance of more than two groups together. So for this, another method we'll use, which is called as ANOVA. ANOVA stands for analysis of variance. And here the variance means the mean that we are going to compare as a performance parameter for all the examples. So let me open this. 1 second. The last session that we have on Wednesday, in that session, I would take you through a completed project so that you can see the flow of everything that we have been doing so far. We'll not be able to see all the tools that we have talked. You can see at least, let's say, 40-45% things that we have said, because in a project you cannot use all of them, but some of those things that we have used, practical point of view, you'll be able to see them. And we'll also solve a question paper together. Around 50 to 60 questions we'll solve together, so that whatever we have discussed and talked, it would put together. So everything would be able, you'll be able to find in those questions. So you can validate your assumptions also. Okay. In this example, let's say you are the purchasing manager for an organization, and you have been asked that you have to purchase the carpets. You have to get the carpeting done in the entire organization for all the floor. So you selected 4 vendors, 1, 2, 3, and 4, and each vendor gave you 4 samples, or you used these 4 vendors sample at a certain floor, and so you have 4 sample from each of the vendor, and this is the performance. So now you want to determine, comparing the performance of these 4 samples from these 4 supplier sample, which is a better supplier, or whose performance is better than others. So if I ask you, what will be the null hypothesis here, if you remember the Friday session? What will be the null hypothesis? Vineet, you were there. So do you remember what will be the null hypothesis here?
Yeah, there's no difference, all the same.
There is no difference. Perfect. So the null hypothesis means that, as I said, 2 things are not same and they are related, and there is no difference. So they are not related and there is no difference. That means all the 4 suppliers are providing you the same quality of carpets, and if you think they are different, you need to prove it with data. So that's how null hypothesis is built. So we are saying the mean. Now we are saying they are all same. They are all same means what? Their performance is same, and their performance is what? The mean of the performance is same. And how we are measuring performance here? Durability. So how do we conduct an ANOVA test here? Analysis of variance we have to do here, because this is more than 2 samples. So we go to stat, we click on ANOVA, ANOVA, and we click on one-way ANOVA. It says determine whether the means of 2 or more groups differ. It says response. So what is response here? Durability, which we are measuring. Factor is a carpet. If you go to graph, it will ask you what all graph you can get from this one. So you can say box plot also you want, individual value plot you want. That's it. If you click OK, you click OK. It will give you some graph. So if you look at this graph, I talked about box plot. This is the performance of carpet 1. This is for 2. This is 3. This is 4. So do you see, is there a variation in the performance? Is there a variation in the
Yes.
performance? There is a variation, right? Because the box plots are of different sizes. Can you tell me which carpet has the most variation and which has the least variation?
4 has the highest variation, 3 has the less variation.
Very good, very good. Least variation, most variation. Very good. Now let's look at the session window and try to understand. That is how the mini tab will give you a session analysis for this entire problem. See, it even makes the null hypothesis for you. Null hypothesis is all means are equal. That means there is no difference in their mean. Same performance. Alternate hypothesis says at least one of them is different. At least one of them. Significance is 0.05. So now we directly jump to the p-value. This section is important, but not right now. We'll discuss regression, and that's where I'll explain you this. So what is the p-value here? This is the p-value. So p-value is 0.04. So what does it signify? And what will we do with the null? Will we accept or reject?
We reject the null.
We reject the null. Why?
It's below 0.05.
Absolutely right. So if you're rejecting the null means, what is the conclusion about the performance of carpets?
They are not the same, they are different. There is a correlation.
Yes, that means the performance of these 4 carpets is not same.
Yeah.
If one of the carpet has a different performance than other. Now, hypothesis testing does not tell you the problem. Hypothesis testing tells you that this is the area you need to look at. And let us say if the p-value, for example, if the p-value was more than 0.05, then you could have thought that these 4 samples are correct and you would not have looked into it then. Then your decision was very clear. You're good to go. But now it is telling you there is a difference. So that is when you would start investigating and you will get more into the problem. So that's where hypothesis testing prioritizes that particular area for you. So this is when we have to have 4 samples and we were comparing them. And we used a ANOVA, one-way ANOVA, analysis of variance, we call it. Now, this entire thing what we have discussed, the 2 sample t-test, paired t-test and ANOVA, when y which you are measuring is continuous and x which is one of the factors impacting y are discrete, we're looking at centering. Now, situation number 2, everything remains same, y is continuous, x is discrete, but now we want to focus on the variation in the problem. So we use another test here, which is called Bartlett and Levin. A Bartlett will be used when normal, data is normal. Levin will be used when data is non-normal. And we'll check it using the mini tab again. Okay, let me move here, 1 second. Okay, so in this example, now we are seeing variation. So you have 3 factors, rod, temp and oxygen. So There is a cold storage where they store the potatoes. Now, cold storage manager is concerned that the potatoes are being rotten for last couple of weeks. So of course, if the potatoes are rotting for last few weeks, it is loss for him because he would lose revenue and he will have less profit also. And he doesn't know what to do. So he called a green belt and said, if you can look into this problem so that I can work on it and save money. So as a green belt, you collected some data and you wanted to now determine, you realize that there is a temperature setting in that cold storage, and there is also a oxygen level also in that cold storage that is helping to make to keep the potatoes safe. So you took the measurements of the oxygen level and the temperature rating. Now you have multiple factors that may be impacting the rotting. One of the factor is that the variation in the temperature and oxygen level. So you want to check whether the temperature and the oxygen level variation, the variation in these two factors is leading to rotting of potato or not, among other factors. These are one of the factors. So at this situation, you want to do a variation test. So now what will be the null hypothesis? Yes, null hypothesis.
None of the factors are connected, so it doesn't matter what is the temperature or the oxygen. It's the same.
Yes, so temperature and oxygen, two factors, they are not impacting the rotting of potato. And if they are impacting, you need to prove it with data. So that is their alternate hypothesis. So null hypothesis, they are not impacting the rotting of potato. So how do we do according to this list? Bartlett and leave-in test. There is no Bartlett or leave-in test in Minitab directly. So how do we do a Bartlett leave-in test to check the variation? We go to stat. We go to ANOVA. Now, here we select the test for equal variance. And what the description is, determine whether the variance or the standard deviation of two or more group differ or not. That's what it tells us. So you click on it. What is the response here, which we have to understand? Response is rot. And what are the factors impacting rotting? Temperature and oxygen. Now, what we have done so far. If you go back to this tab here, it says when data is normal, we have to do a Bartlett test. When data is non-normal, we have to do a leave-in test. Now, if you go back to the mini tab, if you click on options, it is asking you, you need to do the test based on the normal distribution. So if you check this box, then it will assume the data is normal. So it will assume that you have already checked the data is normal or not. So let's say I'm assuming data is normal. So I click OK, and then I click OK. If I go to session window, I get Bartlett test. And I get a p-value here. What is the p-value?
More than 0.05.
So what does it mean?
We accept the null hypothesis.
Correct. It says null is all variants are equal. Alternate, at least one variance is different. So that means at least one of the factors is impacting. That was the alternate. So that means that temperature and oxygen level variation is not causing potatoes to rot. There is some other reason. So obviously as a green belt, you would have done a fishbone, you would have collected a lot of potential causes. One of the potential causes was that the temperature and oxygen level variation is causing potatoes to rot, and you ruled it out. So let us say if you had 20 such causes, you ruled one cause using the hypothesis that this is not important. Now you have 19 more left to test. Such statistical testing is what we're doing right now. So this was when we assumed that data is normal. And if you go back to this table, it says when data is non-normal, you need to do a leave-in test. Go back to this mini tab once again. Now we have to do a leave-in test. Is there leave-in? No. We go to the same thing. Stat, ANOVA, test for equal variance. Same thing, we have to do a same test. In the option, now we have to uncheck this box. Now it will assume the data is not normal. We click OK, and we get this. So now you have leave-in test here. This is leave-in test. Even the leave-in test gives you the same p-value, which says 0.858, which is very strong, far higher than 0.05, and tells us that temperature and oxygen variation is not responsible or is not causing the potatoes to rot. There is something else which is causing the potatoes to rot. And these were some very key and critical tests for you to understand and perform in your day-to-day, I will say, activities in the office, rather than just calculating the mean of a data set and then try to mean which is the average. How good are we doing? So now you start using these tests. If you get stuck somewhere, so you can always contact me and I'll let you know. But that is how you need to use these tests in order to understand the application more and more. If you want to even understand them better, I can give you guys some books as ebooks that you can read and understand them even better. So after this hypothesis testing, what comes next, we'll talk about it, but there are some more tests that is remaining. I'll pick up just one test from this list and then we'll move on. So this is when the data X is discrete and Y is continuous. Another scenario, when Y is discrete and X is also discrete, when both are discrete, both are count data or categorical data, then we are using the chi-square test. Now, let me open a test for chi-square and then explain you one of the tests in chi-square, what it does. Second. Okay, this is the data set here. So let me explain you this data set. Let's say as a researcher or as a greenbelt, you want to understand whether these are different parties, Democrat, Republican, and others. And you want to understand whether is there a correlation between a party affiliation and your gender. Let's say male like some different party and female like some party. Is there a correlation between the gender and your affiliation to a particular political party? So this is what you wanted to understand. So what will be the null hypothesis here in this example?
There is no relation with gender and which party they choose.
Correct, correct. Gender has nothing to do with the party affiliation. So here we need to do a chi-square test. And how do we do a chi-square test? Again, you go to stat. So to do any test, you go to stat as a tab. Now it is a chi-square test. Where is chi-square test here? So we go to tables. Why do we go to table? Because this looks like a table. Go to stat, you go to tables. Now, We are selecting chi-square test for association because we are saying, is there an association between gender and political party affiliation or not? And that's what it's saying, whether the two categorical variables are associated or not. That's why we're selecting the test for association. So in rows, now here if you see, there are two options. Summarize data in a two-way table. I selected this. Why? Because data already looks summarized. Columns containing the table. So I go to Democrat, Republican, and other. And I can click what is stats. Okay. So I clicked OK. That's what it came to me. Now, chi-square test looks a little different than other tests. Here one represent male, two represent female. This is the actual count that you saw in that table. While this number is called the expected value. This is the expected value and this is the observed or the actual value. So you can also look at the number, then see expected and actual are very close to each other. But what is our object? We are looking at the p-value. What is the p-value and what is your conclusion on this?
Accept.
Yes. What is your analysis of this p-value? Will we accept the null hypothesis or reject the null hypothesis?
Accept. It is more than 0.05.
Yes. So we will accept the null hypothesis, correct?
Yeah.
And what is the null hypothesis here?
There is no relation between gender and their party affiliation.
Absolutely. And that is what we are going to accept. And our entire strategy after that will be based on this conclusion that gender has nothing to do with the political party. And if the p-value was less than 0.05, then your strategy to influence different type of voter would have been different. So you see how this analysis would mean so much that your strategy after that would be very different. For example, if you are somebody who is standing for an election in a college, university at level, for let's say at that level. So the female voters and male voter, they will have a different strategy basis the data analysis. And these days, what happens is, which is the truth and a fact now, that all the parties, all the political parties, they use data analytics. I mean, they use them to a level where you cannot imagine them. I mean, huge data is captured and huge data is churned and they analyze it and they use a lot of analytical methods to understand the user, the voter behavior, the sensitivity and so on, different demographic. And basis that they build the strategy. How to target a certain type of voters in a certain place and how has been their pattern. Earlier days, this data was not available so readily, but these days, not only data is available, but also analysis of the data can also be done using different methods. So this is just one of the methods we just talked about to understand the behavior of the voters. Now the same thing can be applied to various other situations also. Let's say if you're launching a new brand and you want to understand different categories of customer, is there an affiliation of different type of customers to a particular, let's say, type of taste or product type or color or anything. So that depends on data and the data is here with you. Similarly, it can be applied for a lot of other situations also. That's where hypothesis testing help you to rule out something. That is it an important factor? If it is not, you will rule it out. But if it is, then you can further analyze that how do I take that forward. So that's why I said before I begin the hypothesis testing that from that point onward, you had to look your problems in a very different way altogether. Because then you have to build every problem in the corporate world or any, I mean, I would say corporate world because In real life situation, obviously you will not go and collect data. But in your corporate world situation, when they are at your office place situation, you may have data around of things that you are doing. Because of course, at your home, you will not make an Excel sheet of things you do. But in office, you definitely have some data around the things that is happening. Escalation, customer complaints, and so on. So it can be a very good tool to analyze it. Okay.
Shivan, I have one doubt in this.
Yeah.
In the menu tab, how did they judge which is male and which is female? Because as far as I'm aware, but I saw, I didn't see any difference in male, female on the values which you gave, like Democrat, Republican, and other. They were just numbers.
Correct. Good question.
So how do they differentiate who's a male and female?
Good question. Okay. Let me look at the data that we have. So if I go here, for example, one second. Labels for the optional. Okay, so it actually took a by default male and female itself. I did not do anything here. That's how the menu tab put it forward. And how it by default, because the data is put in that manner. So when I'm doing the test, the one in male and two is female, because that's how I have stored collected data in this manner. So it is, I have telling you that the data in the first row is male and data in the second row is female. So it is like how I have put in.
Okay.
For example, let's say when you are collecting the data, so you can also, let's say you can add a column here which says gender, and then you can write this is male and female. So it is like I have put in a column here.
Okay.
That's how I said.
Are you sharing something on the screen? Because there's no movement on the screen.
Oh, I'm sorry. Gender. Can you see my screen now?
Mm-hmm. Okay, right. So that's how it is. That's how it took it, because you had saved it like that.
Yeah.
All right, understood.
I had
Yeah,
not added a column called gender of voters, so that's why you got confused.
Yeah. Okay, perfect. Yeah, I just wanted to know if there was some mechanism in the background which also considered the C1T row.
No, it did not. Okay. By the way, you would see that there is a T here and there is no T here. C1 is 70, it's not T. Whenever you put a text in the data field, it will call as T. T means text.
Mm-hmm.
There is no text, and then it's a numerical field. That's
Clear. Thank you.
Thank you. Okay, so let's move on from here. These were the hypothesis tests that we have been doing. So these are all the slides on the hypothesis test. I'll just move from here. So now at the end of the analyze phase, okay, let me open one more. It's like an actual project presentation. That is just to tell you what do we do with those hypothesis tests. Just a second. Let me open it. So let's see, these are all the, okay. So this is a fishbone that has been done, and you collected the data that these are the factors which are impacting the quality score. What was the next step? We are going to check each potential cause versus the why that we are improving. Gender, is gender impacting quality? Is the age impacting the quality? Is the marital status impacting the quality? Is the tenure of the associate impacting the quality? And null hypothesis is none of them are impacting the quality. So we are doing a test. If different hypothesis tests we are performing, and this is what we are doing just to understand the variation. That's it. And you see, that's how we are doing the test now. Different hypothesis test is being done. And at the end of all the hypothesis test, we make a table like this. This is a table that is made that tell us wherever the p-value is less than 0.05, these are those potential causes that we need to consider for further analysis. So out of 4, 5, 6, 7, 8, total 8 potential causes, we are looking at only 1, 2, and 3. That process knowledge, team leader, and mode of communication. These three factors are significantly impacting the why. While other 1, 2, 3, 4, 5, these 5 are not that impacting, are not that important, or they do not have that impact on the overall why here. So this is helping us to filter or prioritize where should we focus more. So that's where hypothesis test at the end, you need to make this table and write the significant X impacting the Y. Let's go back to our presentation. At the end of the analyze phase, the objective of analyze phase was to find the root causes. And obviously after doing the fishbone analysis, one second, just. After doing the fishbone analysis, you collected a lot of potential causes. Then you prioritize them using the, you found the root causes using the 5 analysis, used the control impact matrix to find which are the important factors. And then you looked at the hypothesis testing to statistical validation of what you wanted to check, like which one are the important factors. So control impact matrix is one way of prioritizing it, and hypothesis testing is a statistical validation that you can do. But statistical validation, the only problem is with this test is one factor, the first factor, that most of the green belts and black belts, they are not very good with statistics. They go through this statistics in the training, but they don't use it in the day-to-day life. And the reason is not that they cannot. The reason is that they do not get chance to use it, because most of the time they want to solve problem using the using their own gut feeling and experience and skill. Because they, even if hypothesis testing tells them something, they still want to believe their skills and experience. So it overrides that particular thing. So it takes time to believe statistics, which they are not able to do it. Second thing is that you do not have time to collect data and then look at this. Most of the time you will say, I know what to do in this situation. I have done it a lot and I have seen it in my previous companies, or I've read it in the books that that is the right way of doing it. So you will do it. You will not look at to collection of data, hypothesis test and all that thing, because it is an experiential learning. Until you experiment with it, so you will not experience it. If you not experience it, you will not do it. That's why most of the green belts and black belt, after a few years, they lose touch with all these things and they end up being only the lean expert. So this is a word of caution when you go back to your respective workplace. If you start using it, then only you start believing it. So at the end of the analyze phase, the idea was to get the root causes. So we have the root causes now, which we got through 5 analysis and fishbone diagram, and we did a statistical validation of those root causes by the hypothesis testing. Some of the tools that we use, the Pareto chart, box plot, histogram, hypothesis testing, cause effect analysis. These are the things that we have used it. Now, at the end of each toll gate, be it define, be it measure, be it analyze, there would always be a situation where you may find some fixes of the problem. Those fixes can come and at any given point, because in the improve phase we have to design and build solutions, implement also, but you don't have to wait till improve phase to get a solution and implement it, because the fixes of a particular problem can always come anytime, and you should keep looking for it. Because let's say if there is a leakage of sewer line, leakage of, let's say, a pipe in your home, so you will not wait for a plumber to come and find the root cause and then fix it. Meanwhile, you will try to stop that flow of water by taking some measure. That is a fix that we need to find out for all the problems, because by the time you find the actual root cause and try to fix it and find a solution, there would have been so much of damage, then that solution will become irrelevant then. So you need to always try to find some fixes meanwhile and try to keep the situation afloat and then move on. And meanwhile, find what is the real cause for this to happen. For example, you wanted to reduce the turnaround time for hiring an employee. And that is a project, fine. But let's say if you have to go live in 3 months and you have to hire 20 associates, will you wait 3 months and then say, no, let me first reduce the hiring cycle time and then I'll hire those 20 associates and then I'll go live? Not possible, no? So fix right now is to hire those 20 associates. And meanwhile, try to find the problem that is causing you to get a higher root cause, a higher hiring cycle time. And then you can use the solution in the long run. And in the long run, you'll have the benefits. But if you want to do something in 1 month or 2 months, then using the entire DMX cycle with all those methods will take longer time. That's a word of caution. So as part of improve phase now, there are various things that come into our mind. First thing that come into our mind is the process that we have in play, the process that we want to improve. There are certain steps in the process. There are defects. There are a lot of waste in the process. Do we eliminate them? Do we simplify the process? Or do we rearrange the process? Let me redesign the process. Or do I need to combine some steps or merge some steps? What do I do? That's the key question that comes in. So there are various methods that talk about how to design those solutions. And that's what I have been saying when we started this thing, that there are 2 things that you are doing in a process to improve it. One is you are shifting the mean from where it is to the target. Second thing is you are reducing the variation in the process or making the shape of the process look leaner. These 2 things are we doing in a process. So the solution that you should be building, it should serve both the purpose. It should shift the mean. It should also reduce the variation. But one thing, if you remember, I asked you a question that what is the average of 5 numbers? 5, 5, 5, 5, 5. You said the average of these 5 numbers is 5. And if I gave you another 5 numbers, which were 1, 1, 1, 1, 21, the average was also 5. So in those 2 data sets, you saw the variation in these 2 data sets is a lot of variation. In the first data set, all numbers are same, but in the second data set, all 4 numbers are same, but 1 number is 21. And because of that 1 number, the average is still same. So only reducing the variation will not mean that you are now meeting the target. Because let us say if you are outside the customer specification limits, but let me draw this so then I can explain you better. This is the customer specification limit. This thing. You reduce the variation in the process. Your process now might look like this, but you are still beyond the specification limit. You reduce the variation now. So only reducing variation does not mean you will meet target. You also have to shift the mean of your process over a period of time, because until and unless the average changes in a process, variation will not change. So if the average changes, variation will also reduce. But if the variation changes, average may or may not reduce. This is a very important thing to remember. So you might see that the standard deviation would have become less if you measure it over a period of time, but that does not guarantee that the average has also reduced.
Shivan, can you repeat the sentence? I'm making a note of it. You
So
said like variation.
So for example, if the variation in a process reduces, it may or may not still be meeting the target. But if the average starts shifting towards the target, then the process will be meeting the customer requirement, or then the variation would also reduce, or it is an indicator. If the average is shifting towards the target, it is also an indicator that the variation in the process has also reduced, but it is not true vice versa, that if the variation has reduced, average would also have reduced. No, that may not be true. So we look at some of those key uh, key methods to build solutions. How to build solutions? So one of the key method to build solution is called as the brainstorming. Now I would like to ask this question to all of you, and anyone can answer this. If you have to conduct a brainstorming session, what is your approach? Or have you done a brainstorming session? If you have done that, how did you conduct a brainstorming session? Anybody can speak.
Allow everyone to give their ideas and
Sorry?
discuss how they allow everyone in the team to give some ideas to solve the problem and discuss how good it will solve it.
You will give the people idea.
Like in a team, like we used to have brainstorming sessions like that. So
Hmm?
the lead we used to ask each and everyone how can we solve the problems, or how can we achieve the target uh, before the deadline, like that. So
Okay.
everyone will discuss about their points.
Hmm?
So each and every one of will get an opinion about their idea. So after the discussions, like I feel that's the brainstorming sessions.
Yeah, which is right. What you said is right. That is a type of brainstorming. Okay, fine. Anyone else? Anyone else would like to add on to this or wants to have their own opinion? Anyone? Okay. So what this gentleman said, it is partially true. I mean, I will not say no. That is what the brainstorming is, but they miss the element of brainstorming. What happens is, I'll tell you the process of doing it. So next time when you do brainstorming, you can probably use some of those elements. As you rightly put that you make a cross-functional team and you put together in a room to discuss it. But what do you discuss and how to discuss? That's a process actually. So let us say if you are going to solve a problem and you want people to give the ideas to solve the problem, you want them to come up with solutions. So you discuss first, you tell everyone this is the problem we are going to solve, and that is the business case, and this is the problem statement. So as a leader of that or the facilitator, you need to come prepared with a problem statement that you will use in a charter. Same problem statement. This is the problem. We are facing this problem for these many times. This is the statistics, and these are the figures, facts and figures. And these are the baseline. And if you do not solve this problem, what would be the impact on the business in terms of numbers? This has to be given to every candidate before we say, okay, now this is a problem. Now tell me what you want to solve. No. It has to be a quantitative problem that you give it to the candidate. For this, you have to do some work, collect data, get a baseline, and then go back to the group to find solutions. Step number one. Now you are there in a group. you give each person 10 to 15 minutes and you give them a post-it. You give them post-it and then say, whatever comes in your mind. You find it silly, I may find it important, so please write it. And do not speak, nobody will speak. Next 10 to 15 minutes, everyone only writes their ideas on the post-it. After 15 minutes are over, you collect post-it from everyone and start posting those post-it on the whiteboard. So a lot of them may have come up with the same idea, maybe, or similar idea. So you may strike it out because they are the same one. Now we'll do a round robin, one by one. We'll ask the first person, and if the first person has written 5 ideas, we'll pick up the first idea from that post-it and then we'll ask that person, now tell me the idea that you have built. What exactly is this idea all about? Person will only explain what is the idea and how it is going to help. That's it. Nobody else is, no, there is no brainstorming happening right now. This person has only explained his idea. And then each person one by one will talk about his or her opinion about that idea. Is it a good idea, workable idea, blah, blah, blah. When everyone has expressed their opinion, that is when the group discussion or brainstorming starts. Because until the idea is generated, until the idea is described, and then everyone has put together their points, there cannot be a brainstorming. And then when everyone's opinions are on the table for one idea, we start doing the brainstorming. And can we discuss that idea or not? Okay, what are the pros and cons of doing that? So when you have a long list of ideas, that is the thing, that is a process of doing it. So it might very well take you 2 to 3 days from a long list of potential ideas to discuss and come back with a robust solution. But most of the time people don't do it because they think brainstorming is just to get into a room and start talking and come back. But that is around 5 to 10% effective. And that is why most of the solutions that you figure out, they are short-term solutions and they do not sustain over a period of time. So you again do a brainstorming. So you keep on doing that. So it's a vicious cycle that leaves its mark on the process. But if you want to find robust solutions that should be sustainable, that's the brainstorming process that you should be doing. It might take time, 2, 3, but it will solve you, it will save you the pain that might occur by not having it done properly in the first place. So after 3 months, you may be sitting at the same place, doing the same thing, implementing the same thing again and again. So that thing never, that's where quality always takes time. It is not a 2 hours or 3 hours of thing. It takes time. So that's a brainstorming session that might go on for 2 days or 3 days. But then it's always satisfactory to put in that time. So that's the brainstorming process that everyone should be working. And this is just a suggestion and advice, but depends in what situation you are and what environment you are working and what are your challenges. They may be different. So that was about the brainstorming. Now there is another method which is very helpful, which is a very strong method to develop the potential solutions. It's called as 5S. 5S is a method to keep the workplace clean. It's also a method for visual management. In a visual management, what happens is that it is said that if you keep your workplace clean and organized, then it leads to your productivity. It also makes you feel better about that place. And it is not something which is said, it's a legend which is said. It has been proved, I would say psychologically. So there's a psychological impact to work in a clean and an organized workplace. Example is, let's say you go to a bank, which is not organized at all. There are people everywhere, papers everywhere, and you do not know who to contact, where to go. So you keep asking, okay, which desk and who is doing what. There is no information anywhere. And if you want to select a form to submit the check, the form is not there. If you're asking somewhere, where can I get the form? So this makes you frustrated already. But you go to another bank where everything is so organized. There are desks, there are forms, and it's written on those desks, this is what I do. And it makes you feel that your problem can be solved here. You feel more comfortable, you feel more relaxed that yes, I will be fine. I might take 8-10 minutes. But when you go to an unorganized place, it makes you think, will my problem be solved today? Will I be hurt today? So that's how a normal workplace is also like the same thing, where if it does not appeal you in terms of the first one, the physical appeal is not good. You might feel, I don't feel like working, or I don't feel like doing anything. But that's what the physical appeal of the workplace that we work. But most of the people ask this question, that their physical environment probably cannot be changed or altered. One is, it's already there as it is where they are working. How can I use 5S in building solutions apart from the physical appeal? So apart from physical appeal, 5S can be used in a great way, which we have done it, is a documentation system. So a lot of people find that reducing the turnaround time, which is a common problem where people use Six Sigma, or reducing waste, as part of building solution of such problem, 5S is a very important and good tool. So what happens is, it has been seen that time that you take to prepare a document, to write a document, to write an email, to solve a query, you take certain time. Everyone takes certain time. And if you put together all the time they take to work on that entire process, that is your turnaround time. So how do I reduce it? Then if you analyze it, how do people function and how do they work? If you do a time motion study or we simply observe them, how do they work? You will find that every person, every individual deals with a lot of documents. They deal with a lot of processes which are written, which are not written, or as a standard document. There are a lot of post-it notes on this desktop which they use to copy paste a code or whatever, or a standard reply. They go to various bookmarks in their system which they click and a link opens of shared drive or SharePoint or a website. Or they go to a shared drive to look at a document, or they look at an SOP. So they use all this information, which may be at different places in different formats and different languages maybe. And then they try to solve a problem or to reply an email or prepare a report or solve a request. So when you have a big team or a small team, irrespective of that, it goes back to the same question of variation. If there are 5 persons in a team and all 5 have a different approach toward solving a problem or working on any documentation or a report or a proposal, it is bound to take different timing, and you will have no idea how to reduce this time, because it is not standardized first of all. And the variation is also such that you cannot control it also, because it is very people specific. So how do we do 5S in one of those process? I'll give you an example. Let's say we deal with a lot of documents. So 5S, which has 5S, that stands for sort, set in order, shine, standardize, and sustain. The first thing called sort, which is called, it talks about things that we need today, or things that we need, things that we don't need, 2 categories. A lot of them may be simply archived, old documents. We don't need them. We put them at a separate place. Only thing we needed, they should be in front of me. Okay, all the information is categorized into 2 buckets. Second bucket talks about proper arrangement or set in order. Now, in this, the information that we need today, which is in shared drive, SharePoint, bookmarks, links, and different documents, how much of this document, how much of this information I need it or I use it on daily basis? How much information I use just once in a day? How much information I used once in a week, or bi-weekly, or monthly, or annually, which is maybe an audit or a dashboard preparation? Then I put them into this kind of priority. Now this priority, or which I have also put in when I use that information in different buckets. For example, some information that I use every day. Now, but that information I use for multiple purposes. So as per different type of request, I make different folders. The same information is in different folders. Then third thing comes as shine. Now this information which I have categorized and prioritized, I would see whether it is updated also or not. Legal, compliance, standard wise, any documentation changed or anything, I would change that. With shine, it's called clean it. I would also put them into a standard format. I would make a content table with links so I can click it and find there. That's called shining. That 4th step comes standardize. So what I've just done in one process, I'll do the same thing in all the processes to ensure that only one process is not clean. Every other process also looks same. That's standardization. Because you use these methods, not just at one place, you use this method to all the places. And so you standardize it. And once it has been standardized, you do this every day so that it becomes a culture. It does not become person-specific thing that one person is doing it, another person is not doing it. So organize and visual appeal is not person-specific, it should be process-specific. So it becomes process-specific itself. That culture is like this. Anybody who joins the team, even after 10 years, would be using the same way of making and managing documents. That's what 5S does to everyone. So this was about the 5S, to build those solutions. Identify necessary items, what we need, what we don't need. Sort is put them into different priority or different buckets. Shine is clean them, update them as per requirements. Standardize is ensure that there is standard, the way we are maintaining the standard format, everything, and in all the process we are doing it, and sustain it as a habit, as a culture in the organization. Any questions so far from anyone on this one? Anyone? Okay. If there are no questions, then we'll take a quick 10 minutes break and be back in 10, and then we'll talk about other methods to design a solution. Make sense? Let's be back in 10. Hello?
Yeah, sure.
Right. So guys, I'll see you in 10.
Okay.
Okay, I'm back. Is everyone back?
Yes.
Okay, perfect. So before we went on leave, we talked about the 5S. We talked about uh, brainstorming as a method. There's another very common method of working on what FMEA later on. One second. We look at another method which is called as mistake proofing. One second. So there's another very common and very innovative method which is used to build solutions called as mistake proofing. Mistake proofing is also called in Japanese pokayoke. Pokayoke, like this. Pokayoke. Poka means mistakes, yoke means to avoid the errors. Now, if you look around yourself, the kind of gadgets we use at home, or be it the furniture we use, be it the mobile or car or bike, whichever you drive, laptop or computer system, they all have mistake proofing mechanism. Now, what is mistake proofing mechanism? It's, for example, in buildings you will see there are smoke detectors, and then there are sprinklers, then there is a extinguishers. These are mistake proofing mechanism. What they do is, a smoke detector will detect the smoke, and before, and if it would set an alarm that a smoke has been detected if there's a fire or something of that sort, or a short circuit, and the water sprinklers would start so that fire can be doused. And then there is a fire extinguisher that can be used to douse the fire. So you see, these are mistake proofing mechanisms. They try to prevent an error or a problem that can be controlled. That's how mistake proofing works. Similarly, if you, let's say, if you drive a car and there are seat belts and then there are airbag, if you are not wearing your seat belts, the airbags will not deploy. That's a matter of fact. That is why they say always wear the seat belts, because if there is a collision, the airbags will not deploy completely, and then you will have more and more damage. So airbags can save you. That's why they say always wear seatbelt, not because seatbelt will help you from a collision. If there is a collision, seatbelt would keep you where you are, and you will not. I mean, when a collision happens in that speed of 50 or 100, whichever speed you are driving, you will actually be out of the car. That would be the speed, and if you're and you would break the windshield and get out of the car, and then you will and there would be glass shattered, and it would be all over your place. That is even bad. But when you wear the seat belt, it takes that impact and you stay where you are. That is one. Second, airbags gets deployed, and that will also save you. So that's a mistake proofing mechanism. It has a lot of dial, a dashboard in car that tells you how much petrol is left, how many kilometers you can run with this petrol or the diesel, whichever you use. And if there is a gate open, or if there is the boot is open, it will tell you that that it is open. So these are different dials that tell you that there is some problem. Or if one of the tire has less pressure, it will tell you the tire pressure monitoring system. So these are mistake proofing mechanisms. Similarly, in your home, you have short circuits. These days we have MCBs. If there's a short circuit, so MCB goes down. So that prevents the short circuit. Earlier days, there used to be fuse. So fuse used to get blown. So you used to change the wire in the fuse. That's what we used to. Fuse is a mechanism of mistake proofing. Because if there is no fuse, it will catch fire. But fuse prevents that to happen. So these are mistake proofing mechanisms. But these are again for the physical world, as I just said, that in physical world you can come up with such ideas. And mistake proofing can be of different type. If it's not just this mechanical and electrical, it can be warning also. Let's say you go to a place and it says no parking. That's a warning. No smoking. That's a warning. But if you're going on a road and it says diversion ahead, or speed breaker ahead, or a school is ahead, or you are nearing a village or a town to reduce your speed, or minimum or maximum speed is 100 miles per hour. So that is an alert. So you have alert, warning, mechanical, electrical, all types of mistake proofing that can be built. So how do we build mistake proofing in our process? So for example, audit that is done. Audit is nothing but a mistake proofing mechanism, because audit helps you to understand, are we doing things as per customer requirement? Are we meeting requirement? And if yes, we are meeting, then how good we are. So quality percentage, calculating a quality percentage is a mistake proofing mechanism that tells us how well we are doing with respect to customer requirement. If the quality score some months goes down, so that's an alert that tells you that you did not meet quality target this month. That means something is wrong. But imagine if this quality target, these metrics are not there, then it will not tell you what's happening in the process. So KPIs, I look at KPIs as a mistake proofing mechanism. And that's how KPIs were built, so that they can tell you the health of a process. So when you are looking at KPIs, just do not looking at KPIs that what KPIs we need to look at it. KPIs, you need to look at it not from the process performance point of view, because the moment you look at KPIs from process performance point of view, your vision becomes narrow and you start focusing on the performance. Idea is not to see how well you are doing. Idea is to understand if there is a problem in the process, or if something goes wrong, how will I know? That is why KPIs are built. So if you look at KPIs from that point of view, then you become more proactive, and then you start understanding those KPIs well. And that is when you come up with those KPI that can actually trigger an alarm if something goes wrong in the process, and you would know it even before that. When the problem has happened, it might give you an alert signal, a warning signal. So control chart, for example, if you make a control chart of a process, you will see a trend, a pattern in the control chart that is very close to the upper or a lower control limit. It is not out, but it is very close. So it can give you an alert warning that it might go out of the control limits in future. So that is how mistake proofing as a mechanism. Mistake proofing is just an umbrella, that it is a concept. But there are various things that you can do to make your process mistake proof. For example, people who work on Excel sheets or spreadsheets, they can make the Excel or spreadsheets mistake proof. For example, in one of our project, what we did is, the problem was that the request that we were received, the information that we were receiving from the customer, the information never used to be in standard format. That was one. Second was, there was a template on the SharePoint which they have to use to fill the information. The template was not mistake proof. For example, you can add anything in that Excel. You can add a column, add a row, delete a row, or modify any data. So it's like you can play around with that Excel and do whatever you want. Color, fill anything. If the column says effective date, they can write today's date also. They can write name also. So that means it is just a plain document. They can write anything. So when you receive that document, and if a lot of time information is either not complete or it is incorrect. Like for example, that column says effective date for a change. Someone wrote immediate. Now what is immediate? So now you have to go back to requester, ask for clarity. Some of the, let's say somebody has moved from one place to another, so their pay rate has to be changed because they have changed the location. Now they have not written a pay rate. What pay rate? Because they were not aware that if location is changing, the pay rate also has to be changed. So such validation is not there. Again, you have to go back to requester. I need approval for this change. So very problematic situation here. So we built an Excel document here in template and you put it on SharePoint and said that the template was mistake proof document, that if you name, it will take only alphabets and not numericals. Similarly, it will take date in the DDMMYY format only. And you have to select it from a format that comes in. So if you're typing the date on your own, you can make mistake. There is an opportunity you can make mistake. But if you have to select it from a list, a table, like you see, very interactive list where you have months and years. So it is highly likely you may not make mistakes. So that reduces the chance of making mistake. Similarly, we've set up validations also. If you have made a change in a field, if you have written a field, if you have filled it, so you have to fill another field also, because those two fields have to be filled together. One field cannot be left blank. So we made those validations and we ensure 90% accuracy in data quality. So that was a very good thing that we can. So that's called mistake proof. Again, in the spreadsheets that you work. Now, similarly, people who work in different systems like SAP, they work, People Portal, Workday, different systems they work. So you will see that some of the systems are built in a way that you cannot leave a particular field blank. If you are leaving it blank, you will not be able to submit the form. Similarly, you cannot put any random number into a field. It has to be in a particular format. So these are called mistake proofing mechanisms to ensure that you do not submit an incorrect data. For example, it says you cannot leave this field blank. So people write anything. They will write, let's say ABC, and you will submit it. ABC is 3 alphabet. So another validation, the field your field needs to have minimum 100 characters. So if you're writing A continuously, so another validation is the word that you have written has 100 characters because there is no space. So if you have to write A, then space A, you, instead of doing all this hard work, you will actually write something. So you are bound to write it. So that would ensure this field has less error than it was in the previous. So that is how mistake proofing is a very innovative, very creative way of ensuring that how do I make such mistake proofing mechanism. Mistake proofing is also a trigger. It's a trigger that tells you if there is a problem in the process, or if there can be a problem in the process, how will you know? Can you detect it? Is there a detection mechanism that can detect before a problem should occur? But if there's no detection mechanism, the only thing that is left with you is once the problem has happened, then you will get to know. For example, theft. Is there a mechanism that can tell you that maybe a theft is going on, a theft is happening, a theft may about to happen? For example, people have thief alarm in the home. They have CCTV cameras. So if you do not have a CCTV camera is nothing but a mistake proofing mechanism. Because when somebody steals things from your house, CCTV camera will capture it. It will at least give you some clue. And if you have a thief alarm in your home, so alarm will set off, but it is not stopping the burglary, but it's still a mistake proofing mechanism that can actually alert people. So these are mistake proofing mechanisms that can be as creative you are. So that depends on currently how you completely work on it. So the question is, how do I know which step of the process I need to mistake proof? That's a common question. So you go back to the same example of the swim lane and value stream map, because swim lane and value stream map tells you how the information flows from one end to the another. So you would also know what are the steps in the process that are more prone to errors, that's where most of the manual work happens, in which step. So each manual work may lead to some errors, or it can delay the process. So those steps you need to identify using either a SciPog, a swim lane, or process mapping. Any process mapping tool you should use to identify where can I use mistake proofing. Some of the examples these are. I'll show you a video on mistake proofing. That's very interesting.
Mistake proofing in an office. Mistakes are often attributed to human error.
This is Jamie? Yeah, I just hit print. Okay. Let me grab that print. This is Jamie? Yeah, I just hit print. Okay. Let me grab that printer. No. I'm sure of it.
Looking good today, Jamie.
So why do we make mistakes?
People don't mean to make mistakes. They usually happen for a reason. Rushing to meet deadlines, little or poor training, and distractions. Let's categorize these errors.
It's 3 agencies of government when I get there that are gone. Commerce, education, and the, what's the third one there? Let's see. Oh, 5. Okay. So commerce, education, and the EPA? EPA. There you go. No, okay.
Let's stop deposition.
Seriously?
Cause defects, wasting time, money, materials, and effort.
How do we eliminate defects?
Mistake proofing aims to eliminate errors and to reduce the likelihood of them occurring. Do it right the first time, every time.
So that was about mistake proofing and how do we reduce them. Any questions so far from anyone? Okay. So now what we have done is we are generating ideas using different methods like mistake proofing, 5S, brainstorming. I'll show you another video from Toyota production system, how Toyota as a company uses these methods in their day-to-day life, in their processes, how do they engage people, and how do they use lean as a method, and why are they so successful in using lean, and in what way do they use lean in their daily operations. So that's a very good video that will put the entire thing together that we have been discussing so far, and to tell you that how data organizations use lean and Six Sigma methods to make world-class products and engage the customers.
Toyota, a name associated with quality products, is considered by many to be one of the world's greatest manufacturers. This worldwide reputation is based on a specific way of manufacturing called TPS, the Toyota Production System, created to benefit Toyota's customers, employees, and products. So, what does this mean for our customers and their businesses? TPS is an expression of the Toyota Way, a philosophy containing 5 core values: Genshi Genbutsu, Kaizen, challenge, teamwork, and respect. These values are practiced and shared by all Toyota team members at every level in their daily work and relations with others. The origin of this philosophy was first conceived by Sakishi Toyoda, who invented the first automatic weaving loom. Improved versions of these looms would stop themselves automatically if a thread broke, so that product quality could be maintained and waste avoided. However, the true architect of TPS is Taishi Ono, who in the early 1950s drew inspiration from American supermarkets. He marveled at the way the shelves were hardly ever empty because they were restocked so quickly. Customers could choose the exact products they wanted in the exact quantities they wanted. Today, this is called supply-on-demand manufacturing, also known as lean production. This means that the production process will only be launched after the customer has placed an order. Once the production commences, parts arrive just in time at the factory and on the production lines, and the supplies are regulated in accordance with the exact production requirements. Like a pillar, just-in-time plays a key role supporting the Toyota production system. On the production lines, Kanban cards are employed to replenish parts just in time when stocks become low. The time it takes to produce a component or a truck is recorded, and these are called takt times. These times and work cycles are carefully monitored, then coordinated through detailed scheduling called heijunka. Heijunka ensures that production lines run smoothly, without interruption, even when different products are being manufactured simultaneously on the same production line. TPS is all about creating efficiency. Even wasteful processes and time lost are named. They are called muda. One of the main objectives of TPS is to reduce and eliminate all muda, so that time and production are managed with maximum efficiency in a way that does not overburden either an individual, a workforce, or a machine. In consequence, all workers can concentrate on their tasks and deliver better quality products. The second pillar that supports the Toyota production system is jidoka, or making abnormalities visible. Every team member is empowered to stop the production process whenever a potential fault is detected, so a solution can be found immediately. This means that any problem is made visible on the factory floor and is displayed on the and-on boards as soon as it is detected during the manufacturing process. Should a problem occur, Toyota team members are always encouraged to examine its origins and to practice Genshi Genbutsu, which means going to the source, finding the root of the problem and solving it to ensure production quality. Standardization of the manufacturing process is intrinsic to the Toyota production system's success. Developing and relying on standardized work tasks streamlines the production process and ensures consistently high levels of quality. Overall, jidoka enables Toyota to provide customers with reliable, durable, high-quality products that offer customers better productivity for their businesses and, in consequence, provide a greater return on their investment. One of the foundations of the Toyota production system is Kaizen. This means continuous improvement. Fundamental to the Toyota production process, Kaizen can be considered as both a process as well as a philosophy. At regular scheduled meetings, team members are invited to give their opinions and share their suggestions for any improvements. Inevitably, these meetings encourage and create teamwork. In a typical year in our European factories, more than 3,000 proposals for improvements are suggested and considered. Perhaps this is why the Toyota production system has also been named the Thinking People System, as it relies on total commitment from everyone involved. TPS is present in every aspect of work and builds respect. All team members are requested to play an active role in keeping work environments clean by employing the 5 S's: sifting, sorting, sweeping, spick and span, and sustain. Clean and tidy work environments benefit the entire production process. Regarding the global environment, TPS is more than willing to adhere to government standards. As the environment concerns both Toyota and our customers, our 3 European factories are all ISO 14001 certified and are fitted with the latest technologies to manufacture products that have the minimum impact upon the environment. Within the Toyota production system, safety is also of paramount importance. Most of Toyota's manufacturing sites are certified or striving for OSAS 18001 certification, so that all team members work within respected standards in a safe and healthy environment. TPS creates a safe and responsible system, producing innovative, safer products that benefit the customers and their drivers. Safer products lead to improved productivity, which creates lower overall costs for the customer. TPS, a unique production system that enables Toyota to face all challenges and manufacture products of the highest quality, products that are cost efficient and whose delivery will be on time. TPS respects the environment and adheres to the highest safety standards. TPS, the Toyota production system, a proven world-class system benefiting Toyota's products, our customers, and our team members. Toyota Material Handling. Stronger together.
So that was about how Toyota uses different lean methods to incorporate them in the entire culture. How do they involve people from across the organizations? How do they gather those ideas? How do they brainstorm those ideas? How do they find and how do they use these ideas in building their products? And in the process, of course, engagement of people in Toyota's in an organization has been really in the forefront. That was about how Lean Six Sigma is used in Toyota production system. Okay, so what we have discussed so far, we have, as part of improved phase, we are talking about how do we build solutions, and we discuss some of those ideas, be it the brainstorming as a method, be it the pivots as a method, or be it the mistake proofing as a method. But building solution is not the only objective of improved phase, because the solution that you're building, it also needs to be assessed whether that solution will work or not, of course. And we also need to assess, is there a risk while I develop that solution? So the appropriate risk need to be identified and assessed, and then a rectification or a ramification plan has to be built, that how do I reduce that risk in the future, and how do I eliminate that risk in the future. So what could be potential failure mode of a solution that you are building? So for this, we will use a method. We will study a method which is called as failure mode and effect analysis, that we will use to study. It's called failure mode and effect analysis. So what is failure mode and effect analysis? For example, let's say as a solution, you build a website. Or for example, you already had a website, and earlier people were not able to purchase things online from a website. Your website only showcased the product in your shop, but people can't purchase it. You can only look at it, what are you selling. So for customers' ease and for better customer experience, you added a button called online payment. That's a new solution you added to increase the revenue. Now you launch that option called e-payment or online payment. So you can select things, you can buy it online. But what happened is when you launched it, customer faced a lot of issues. Those issues were like, first of all, payment were not happening in a lot of cases, not accepting a card, not able to add a payment method. Or I can see my product in cart, but when I go to the payment gateway, payment fails. Or sometimes product is available, but it's not coming to the cart. Payment is getting deducted, but it is amount is getting deducted, payment is not confirming. Multiple such issues started coming in. So that means the payment system that you launched is not effective. Something is wrong. You did not anticipate all this. You thought it's a simple thing. I'll simply have a payment option. It will happen. But now people started buying in bulk and you did not anticipate this. When you say you did not anticipate this, this means you did not anticipate what could be potential problems while you build a solution, because you did not assess. You did not anticipate what could potentially go wrong. So we need to understand what can potentially go wrong. And this potentially go wrong is called as a failure mode. Similarly, when a website you are launching, it may be that your website is not opening or is very slow. It takes time to upload. You know, when you click on one link, it does not take you to another link. It stays there. It hangs a lot. So these are all the things which are the risk when you launch or when you start or build a solution. So we need to know what can potentially go wrong in a process. For that, we use a method called as failure mode effect analysis. So let me talk about this template. One second. One second. So this is a standard template. This is used to conduct a failure mode and effect analysis. You can also call it as assessing the risk here. So in this form, the first step that talks about what are the steps in the new process that you write here. So you write those new steps here. And then the second column talks about what is the impact of that step on the business if something goes wrong. So second step talks about what are the possible failure modes. When you're performing that step, what can potentially go wrong. The third step talk about what would be the impact of this failure mode onto the business. Then you write the severity. Severity is a scale that ranges on 1 to 10 scale. A severity of 8, 9, 10 means it's very, very severe. A severity of 9 or 10 means it is that severe it can shut down the business. Severity of 1, 2 means it is not severe, it's just some small issue. And the severity is of that business impact that we are talking here. And then potential causes. What causes this particular failure mode? What are the root causes of that failure mode? Why it happens? So you write those root causes. And then you again have a scale called occurrence. The root cause that I'm talking about, how often does it happen? Again on a scale of 1 to 10. A scale of 9 to 10 means it happens almost every time. But an occurrence scale of 1 to 2 means it does not happen every time. So on a scale of 1 to 10, you have to rate that particular root cause, that how often does it happen. And then you talk about detection. In the failure mode that I'm talking, is there a way to detect it? If there is no way to detect it, you write none. And then again, there is a scale called detection scale. So detection scale of a 9 or 10 means you cannot detect it. You will never detect it unless it happens. And if detection scale of 1 or 2 means that you can detect it every single time it happens. And then you have 3 numbers. You have number from severity. On a scale of 1 to 10, you have a rating here. On occurrence also, you have a rating of between 1 to 10. In detection also, you have a rating between 1 to 10. You multiply these 3 ratings and you get a number called RPN, risk priority number. And that number, so for different failure modes, you'll have different RPN, different risk priority number. So whichever number is highest or the higher, we'll prioritize them. We'll pick up them first to reduce the risk. So that is the first section till RPN. Once you know the potential risk that you wanted to identify, you move to the next section wherein you write the solution for these failure modes. What am I going to do? The recommended solutions. You write who is responsible, then you write what is the actual action that has taken. Then after 2-3 months of finding, you prepare this FMEA, you build a solution, and then you implement the solution. And after a month or so, once you implemented solution, you again calculate the severity, occurrence, and detection, and RPN is calculated. So if the RPN is reduced, which means the overall risk is reduced now. We'll understand this using an example that will help you to understand. So for example, this I was talking severity 1 to 10 means 10 is very severe, 1 is not severe. 1 is occurrence, 1 is not likely, 10 is almost every time. Detection, 1 is likely to detect, 10 is like you cannot detect it. So here we look at an example. There is a coffee shop, and you as a green belt is hired by the coffee shop because their revenues are dwindling. Their revenues are not as per the targets, and they are in huge losses. So they want to understand what is wrong with our coffee chain. You as a green belt were working in that department, and you said, let me look at it. So you identified that for a coffee shop to perform well, there are 3 areas. One is the product, the coffee. Second is the infrastructure, which is the seating arrangement, the ambience, and so on. And third is the customer service. These are the 3 elements for every coffee shop. Because people can have a good coffee roadside also, but you offer great ambience, music, and a good customer service so that people come to you and pay a premium on this. So these are 3 areas. So we are going to prepare an FME on one of those areas called the product, on the coffee. And on that coffee, we look at the process of making the coffee. So this is the process of making the coffee and taking an order and serving it. And in that process, we look at only one step, which is called fill the carafe with water. So imagine I'm going to make an FMEA for that one process of making the coffee, and I'm picking up only one step. And I'll have a big FMEA. Imagine the length of an FMEA for this entire process. So let's see, I'm going to fill the carafe with water. I'm only filling carafe with water, and I'm going to find potential risk. What can happen or what can go wrong while I'm filling the carafe with water? The first step I say is filling the carafe with water. What can go wrong? What will potentially go wrong is that there may be wrong amount of water. or the water is too warm, or the carafe may not be clean. That can potentially go wrong. And if there is wrong amount of water, then what would be the impact on business? Coffee would be too strong or too weak. And if water is too warm, coffee may be too strong. If carafe is not clean, then there can be foreign objects in the coffee, or there may be a very bad taste of the coffee. Severity. If coffee is too strong or too weak, something severity would be around 8. Obviously, customer will not like it. It's a bad product. If coffee is too strong, again 8, bad product. If foreign objects in coffee are bad taste, very bad taste, then you are giving it as 10. 10 is like, obviously, why would someone like to see something else in their coffee apart from coffee? A bad taste means it's actually a very bad taste. So you can say 10. Customer is there to have coffee. The coffee taste itself is not good. They will not like it. Now, these are the severity scale for these business impact that we are talking here. Now, I'm trying to understand what can be potential reasons, root causes for these failure modes. Wrong amount of water. What is the root cause of it? Root cause can be there are faded level marks on carafe, or water may have spilled from carafe. Okay. How can water be too warm? Reason can be faucet is not allowed to run and cool, or employee not aware of new need for cool water. Okay, then carafe is not clean. What can be reasons? Reason can be carafe is not washed, or carafe is stored improperly. Let's try to understand how often does these things happen. Faded level marks on carafe, how often does it happen? It's not very frequent. It happens very rarely, but yes, it happens. Water spilled from carafe, sometimes it happens. Let's say out of 15-20 coffee I make, 3-4 times it happens. Faucet is not allowed to run and cool. It's very, very frequent. Very frequent. Employee not aware of new need for cool water is also very frequent. Carafe is not washed. This is not frequent one. It happens rarely. And out of 100 coffee I make, around 2-3 times it may happen. And carafe stored improperly is 7. That means it's also very frequently. So how will you know that any of these things have happened? How will you know there are faded level marks on carafe? By visual inspection. So you can do a visual inspection. Okay. Water is spilled from carafe. How will you know? I will not get to know. None. Faucet is not allowed to run and cool. So how would you know? By dipping your finger into it. This is the mechanism. Employee is not aware of new need for cool water. You will not get to know this thing if this thing has happened. Carafe is not washed. How will you know? By looking at it. Visual inspection. Cafe is stored improperly. How will you know? If you need to train them, so then only you can measure it. Now, detection mechanism that we have written is, how effective is that? Visual inspection. Detection mechanism is 4. 4 means good detection mechanism, not very good, but at least something is there. None. You can say it 9 or maybe even 10 also. Dipping your finger. Now, dipping finger may not be a very hygienic mechanism, but it's a mechanism that tells you faucet is not allowed to run cool. Employee is not aware of new need for cool water. None. 10. Carafe is not washed. Visual inspection 4, which is a good mechanism. Carafe is stored improperly 5. It happens sometimes. So now we have to calculate the risk priority number. We have calculated the severity, occurrence, and detections. And I multiply, I get these numbers. This is the risk priority number of each of these risks. So now question to the group. How will you prioritize these numbers and on what basis?
The bigger the number, that should be the first to be prioritized.
Which is this, 560. Right? So, as you correctly said, the bigger the number should be prioritized. But there are 2 things that you should always remember. While this is a very good mechanism to put the data and let the data give you insights about the problem and the risk in it, but let not the only data give you the insights. You should always put together your domain experience, your knowledge skills also to an extent. So you see what I'm talking about? Both these things, there has to be a balance. Do not become completely blind by your own experience and skills, and do not become completely blind by the data itself. You should have both these things to your disposal, your knowledge and experience. And second is the data. Put them together and then make a decision. However, the 560 says that's the most critical one that you should look at. So now how do you look at or read this table is, look at each of those numbers. Where is the biggest impact, or where is the highest severity item? These are the two highest severity items. Foreign objects in coffee, bad taste, because these two things, and then second are these two. These two can actually make or break the reputation of your coffee shop if they are not handled properly. People can click picture of foreign objects in coffee and post on social media. That can ruin the entire reputation, and your business might shut down also. So you want, now this is urgent and important both, but you want to check the occurrence. Occurrence is very less. That means it is not happening frequently. That's a relief. Inspection 4, that is also fine. It is not happening frequently. So, okay. And I can detect if it happens. So if it is 160, okay, I don't have to pick it up. What about this? Bad taste. Cafe stored improperly. Rating is 7. Occurrence is 7. That means it's frequent. And it might also lead to something in the cafe also. It might lead to foreign objects in coffee as well if it is not stored improperly. And then detection is 5, which is not a very good detection. So, however, it is not very high, 350 compared to 560. But this is an area of concern because this directly corresponds to a high severity area. So you should prioritize this. That is put together a knowledge skill which has the high severity, high detection and low, high occurrence and low detection. Whichever has a low detection, that you should prioritize first. Low detection, high severity. That is how you should prioritize. So what next? Next is that for all these issues that we just found out in this process, we are going to build the solutions. These are all the solutions. Replace the cafe, train employees, appoint inspector before storage, that it is clean, it is stored properly. Cafe stored, bin and train employees. And these are the people who are responsible. The next is, what is the actual solution that is taken? These are the recommended solutions. This is the actual solution. Now all the solutions were implemented, and after a month, again we calculated the risk priority number, and you saw the risk priority number is now reduced. It was 560 earlier, now it is only 64, which is a very good thing, almost 90% reduction. But I have a question to ask you. There is no reduction in the severity. Occurrence and detection numbers have improved, but severity numbers have remained same. Can anyone explain why?
Because those are some scenarios that will truly happen even if you have the best control in your company.
Exactly. Yes. Very good. So that means the severity of a risk will never change. The severity will remain as it is because the risk remain as it is. However, your ability to detect that risk might improve. The occurrence of that risk also may reduce, but the severity will never reduce. That will remain as it is. Very good.
You can also say that the severity is the effect and occurrence and the detection are the variables.
No.
So the variables are reducing, the severity is like the effect of if those variables don't change, right?
No, they are not cause and effect. Do not get confused.
Okay.
If you look at it that way, then that might lead to some errors while you are preparing an FMEA because your thought process will change then. No, don't look at it. Treat them as an independent, I would say, an independent factor itself.
Right. Okay.
Cause and effect method will help you to find what are the potential factors. So failure modes are nothing but potential factors that, and again, by the way, brainstorming you need to do for preparing an FMEA. You need to do okay, so I go back to the brainstorming thing. So whatever tool that I have talked about, 5S, mistake proofing, FMEA, fishbone, SIPOC, all these things you have to do a brainstorming, because brainstorming means you have to put the team together to work on all this. So when you are using the FMEA, the brainstorming here happens on what should be the rating. However, there is a scale, but people need to agree on this is a scale they think. And severity is treated independently. And when you look at occurrence, then occurrence is related to severity. Detection is related to the, the failure mode itself. So there is a correlation, but there is no cause and effect that is happening here. But that would completely take the essence away of the FMEA. So again, as I said earlier also, however, it is part of the assessing the risk of a new solution or of a new design or a new process. And you're using it into a Six Sigma project in which you are developing a new solution or improving an older process. But as I said earlier, that you should always use these tools as in standalone tools. Like you are a new operation manager. You have recently joined, and the team is performing fine. However, you are a green belt, and you have read about FMEA. So you have a process map of your process. Every process has, you also have an SOP also of your process. So you made it mandatory that all processes should have an FMEA also. And that is how you should also look at it, all of you. But you should also always prepare an FMEA of your process. Just like you prepare a SOP or a process map, you should always prepare an FMEA that can tell you what are potential risks in performing a job, how often does it happen, and how is the detection mechanism. And you should revise or update that FMEA and after every 6 months. FMEA is a very critical document that all like for example, wherever I worked, I ensure that FMEA should be there as part of the documentation. That's a critical document. It tells the leadership or people who are managing the operations or that work, how well prepared are we if something happens, or what are the risks that I know. No problem in your process should come to you as a surprise. If you do not have an FMEA, what will happen is you will treat each problem as a project, as an independent problem. How do I solve this? Another problem comes. Okay, now how do I solve this? So you will only be doing firefighting and solving the problems, but you know that they are all related to just one thing. So FMEA can put all of them together at one place. And by the way, how an FMEA is being built, it is coming from the process. Where is the process coming from? That's where the process is coming from. This process, which is nothing but SIPOC. It is SIPOC. There is no supplier or customer. You can add it here. You can have a detailed SIPOC here like this. So that's how the SIPOC and FMEA are very important and strong document that you can build and use it in your own process for day-to-day use, operation, visibility. And it is irrespective of industries, be it sales and marketing, be it operations, finance, supply chain, marketing, HR, anywhere. These are very common documents that can help you to build a lot of stuff. So this was about FMEA. Tomorrow when we connect, we'll talk about, now we have assessed the risk, we have built a solution of what now, how we have to now test our solutions. We also have to build a predictive model, which is called regression, that we'll understand tomorrow. And one more tool called design of experiment at a very brief level, we'll understand tomorrow. And then we'll look at the control phase of the green belt. On Wednesday, we'll do a full-fledged project. We'll look at it, we'll do a recap, and then we'll go through certain questions. Any question from anyone on so far from today's session on our last week's sessions? Okay, no question, perfect. And by the way, the group is very silent, the WhatsApp group, so no one, okay, so I assume that everything is clear to you because no one asked any question in the group. And
about the FMEA.
Sorry? The full form.
The
failure mode and effects analysis.
About the detection. From the last slide.
What is the question?
Yeah. If if we have done something with the problem, why is it that the detection rate goes down?
Okay, so detection works inverted. Inverted means, for example, severity 9 or 10 means it is severe, very severe. Well, detection is opposite. 9 or 10 detection means it is bad. There is no detection. Well, detection 1 or 2 means very good detection. So to make severity or good detection all are 10 10 10 means that means the problem is big. That is why detection scale 9 or 10 is this way, so that if it's bad, it should be bad at the higher level, 10 10 10. And detection of 1 or 2 means you are in the good hands, everything is good. Occurrence of 1 or 2 means absolutely good process, hardly it happens. Severity 1 or 2 means there is no severe issue, it's very simple. So if you multiply those 1 to 1 1 1 rating, that means there is hardly any risk here. That's where detection is other way around.
Does that not conform with the common thinking that if the process was let's say was corrected, or the process was being made better, the detection rate will increase?
No, that is how the scale is set up. Don't get confused. We have set up the scale in such a way. For example, let us say if I go by that rule that you said, my detection should go up. So if your detection goes up, your RPN will also increase. That should not happen, right?
Yeah.
Right? So that is why we have inverted the detection scale.
Okay. So you mean the better the process, the lesser the detection rate?
Detection on a scale, yeah, because in the scale, a less number mean better detection ability.
Okay.
Yes, that's right.
Okay.
A number high in the scale is, it's like, look at this way, 1 means very good, 10 means very bad. Very good, 10 means very bad. And this is the same scale. Severity, 1 means very good process. There is no severity. Number high severity. Occurrence, 1 number is it does not occur at all. Detection number on a scale of 10 occurrences, it is happening every time. Same scale 1 to 10. Detection 1 is you can detect it every time, and number 10 is you cannot detect it at all. So number 1 for severity occurrence detection refers to very good process. Number 10 on severity occurrence detection is very bad. That's how it is taken.
That's clear. Thank you.
Perfect. Any other question from anyone? Okay. Okay, perfect. If there are no questions, then we'll resume here and we'll connect tomorrow again. And if you have a question, you can always send me on WhatsApp and we can talk about it. Otherwise, we'll anyways connect tomorrow and do a recap.
Okay.
Thank you.
Thank you. Bye bye.
Thank you, everyone. Bye bye. Good night. Take care.
Yes.